so everybody clap their hands. Clap your hands 3 times. Okay, so why did you clap your hands? So because I told you, right? Okay, so alright, so you all clap your hands because I use a language to tell you guys to clap your hands, right? And you know, similarly to how I use language to make you guys clap your hands, I can also use language to make a computer do something. And in the case of computers, you don't really talk to people, you know, using language to talk to people. You use a language to type. You type a language into the computer to make it do something. And you know, similarly to human languages, you have many different types of languages like Python, C++, Haskell, and whatever language you can name. And you know, in the past few months, I've been learning C++. It's a very specific programming language to tell the computer what to do. And in this day, we live in a digital world where everything is almost digital. Your phone, your computer, you know, your refrigerator, your microwave, even your shoe, maybe. Your microwave keeps track of what numbers you put in. The vending machine checks if you have enough money put in, you know, like in your cell phone. Obviously, it does a lot, right? And you know, today, so I'm just going to show you, like, you know, the basics of how these things are programmed, and you know, you want to know how they're kind of done. So I'm pretty sure all of you are familiar with the term software and program, and yeah, I'm going to show you today how they're made. So before I talk about how software and programs are made, you first need to understand what algorithms are. Now, what algorithms are, they're just a series of steps on what to do, like 1, 2, 3, 4, 5, and you follow in sequences. And algorithms are not necessarily for something for computer science or mathematics. It's like, it could be like something like cooking instructions. You know, you follow the steps on how to cook, and it could be like walking to class. And you know, we use it all the time. Like you know, if you were to get to speech class, you would first, you know, go up the stairs and then, you know, get to the door and then find an empty seat and then you know, sit in an empty seat and then, you know, listen to me. So if you apply the term algorithm to computers, it's just literally making the computer follow a series of steps on what to do. And the term program and software is just, you know, algorithms, but in digital form. It's just algorithm for computers or digital devices. Now, we all use a mouse and keyboard to make the computer or, you know, the touch screen to make our digital devices to do something, but most people, they don't create software or programs for your digital devices. So there's 2 types of people I'm going to identify. There'll be end users, people who just use a computer or the digital devices, and there'll be programmers and software engineers who make the programs and softwares. Alright, so I'm going to show you a very simple vending machine program, a simulated soda vending machine program that'll it won't be complicated. So here's the diagram for the first one. So the first one will be just like you run it, and then it'll give you a soda, and then it'll end the program. And then I'm going to show you how it looks. So I'm going to go into. Okay, so I wrote this in advance, and then since I wrote it, I'm going to have to compile it, since the computer does not understand the actual code that I just wrote. So I'm going to have to compile it. Okay, now I compiled it. It's now in the form of 0 and 1s. So now the computer can understand it, and now we can run it. Okay, so now you're a soda. Obviously, you can make it more complicated. Like you could give the user a choice. Like you actually use it for soda, and if they say yes, they'll look at soda. If they say no, then they won't get any soda, and then it'll end. So Alright, so here's the code for it. Obviously it's a little bit more complicated. So we're going to compile it. Okay, now we're going to run it. You want a soda? Press no and say yes. And now we got our soda, and then now we got a program. Now what if we go back and say no? Obviously you don't get a soda, and it follows exactly what we specified in the algorithm, in the flow chart, in the diagram. Okay, so the first two programs are okay, you know, like they just run it once, but what if you want to run it repetitively? So, okay, so, you know, you can, as long as they keep saying yes, they'll be given soda over and over and over again. And then if you say no, the program will give no more soda, and then you'll be the end of the program. Here's a code that I've written for this third example. A whole lot longer, more complicated. Now I'm going to run it. Okay, so do you want a soda? Yes, we're getting one soda. Okay, now you're getting two soda, and then obviously you can go on forever and ever and ever, and then until I say no, then the program will end. Alright, so, you know, they're just really simple programs, and you know, you could write much more elaborate software, and you know, with much more elaborate techniques and methods. And you know, different programs and different software achieve different things. And to achieve different things, they must be designed with different algorithms, and they must be written in different ways. So basically, it begins with the design of the algorithm. And you know, when you write the code and then you first begin with the design of the algorithm, and then you write the code for it, and then you compile it into 0 and 1s, and then once the code has been compiled, and then you run the software. This is virtually true of all digital devices that you use today, for your phone, for your, you know, whatever. So today we talked about programming language, you know, the different types of people who use computers, the end users, the programmers, the software engineers, you know, what algorithms are. You know, I've run through several examples of programs, and you know, I've talked about the steps of how the programs are made, you know, the design of algorithm, the writing of it, the compiling of it, the running of it. So, you know, if you go out today and your laptop's not working, or you know, your iPhone's or your smartphone's not cooperating, you know, someone didn't design it correctly. So, you know, maybe in the future you'll be one of those people who, you know, will be making software and programs for people to enjoy, and maybe get angry over.
All right, Bryan, the opening is fine. You've got a nice analogy to getting us involved. You tell us what the topic is. I think that works pretty well. I think there is a structure in the speech. I think your preview did not get to be as distinct at the beginning of the presentation as you wanted, because you started talking about algorithms before you even set up what the content and where we were headed during the speech was. So you want to be a little bit careful about that. It felt like you kind of rushed ahead when you were getting into the material. You are a little script dependent, especially at the beginning. You tend to look down. As you get into the speech, I think you do a better job of integrating the audience into the speech and looking at them and trying to be responsive to the feedback that you're getting from the audience. I thought you had some good indicators and gestures where you were talking. Listening to you, your voice, there's good variety there, and you project reasonably well. It's paced pretty well. There are those awkward moments where you were putting in the program programming language, and you're trying to show us that. And that's something that's just, it's numbers. We don't get a chance to really understand it. You kind of explain how it's connected to the process that you're talking about. But, it's like, and behind here the magic happens, pay no attention to that. And so you need to sort of explain that you don't really have time to go into all that. It's really a lot more elaborate, all the O's and 1's that you're putting in here and that sort of thing. But basically, here's what it tells the program to do. And I thought you had some good illustrations on that. I thought that those worked pretty well at explaining the concept there. All right, thank you.